All right, so I think we're going to start with quadratic equations 9.1. Clean that up a little bit. All right, so the first thing here is Chapter 9 is all about quadratic equations. We've already solved quadratic equations by factoring, but now we're going to look in Mod 9 different ways to solve quadratic equations depending on what's given, depending on what we're able to do. And the very first tactic or line that we're going to take is how do I solve quadratic equations with the square root property. And a big tip off on that you're going to be able to use the square root property, right, if we're looking at these examples that I have written down already, right, is notice that they all only have one x term in them. If you only have one x term in the whole equation, albeit it's an x squared term, if you only see one x, you can solve for x. Right? I can solve for x in all of these cases, but if I had an equation that was like 3x squared plus 2x minus 1 equals 0. Right? This becomes harder to solve for x because I have two different x terms in my equation. So we have to do something like factoring, or maybe another tactic that we'll learn later in Mod 9. Right? But because these only have one x term in the equations, we're going to be able to solve for x pretty easily. Right? So we're going to use, so I'll write that down, 1x term in equation. I think most of the time in the directions it'll tell you to use the square root property, but if it doesn't, the way to identify it is that. All right, once we know we're going to use the square root property, first thing we're going to do is isolate the squared expression / term. Okay, so in all these cases, x squared, okay, it's already by itself. In this example, right, the 4x squared, or just the x squared, we want to isolate. And over here, this whole expression that's being squared, it's all by itself, so it's isolated. Right, but once that squared term is isolated, we can take the root of both sides. When you take a root, we want to remember plus and minus for roots. Because I take the square root of 81, there's actually two square roots of 81. 9 times 9 is 81, and -9 times -9 is 81. So we want to make sure that we remember using a plus and minus. And then if we need to, you might have to do some solving at the end to isolate the x. Okay. All right, that's pretty much it. Let's go through these three examples, and that'll be it for the first part here. So in this first example, it's already set up perfectly. I have the x squared term all by itself, so I don't need to isolate anything. I can just take the root of both sides. So I'm going to take the square root of both sides. And remember, don't forget the plus and minus. So when I take the square root of 81, there's going to be two answers to that, plus or minus the square root of 81. And as we saw in Mod 8, square rooting a square, those operations are inverses of each other, so they cancel out. We have x equals plus or minus the square root of 81 is 9, and we're done. All right, for 2, I don't want to square root yet, because if I square root now, I have to square root the whole left side, and I can't take the square root of that very nicely. I can only take the square root of each of these pieces. So we want to make sure the squared term, or the squared expression, is isolated. So in order to do that, we can subtract 49 from both sides. Then we can divide by 4. So x squared equals negative 49 over 4. Okay, and now we got the squared term by itself, which means I can use the square root property just like above, and this will solve for. And don't forget the plus or minus. So that's going to give us x equals plus or minus, right? And remember from mod 8 that if I take the square root of a fraction, I can take the square root of the top and the bottom. So the square root of negative 49, right, is going to be 7, right? And because of the negative, remember that's going to be imaginary, so 7i. And then the square root of 4 is 2. Right, and there are the two answers to that quadratic equation. And lastly, in the most complicated version of this, you have a couple of these like this. Right? The nice thing about it, though, is that it's already, the squared expression is already by itself. I can't touch anything that's in this expression until I cancel out the squared. So we're going to start off by taking the root of both sides. Plus and minus. The root will cancel out the square. So we have 6x plus 1 equals, all right, in this case, 15 doesn't have a nice square root. We can't even reduce it. So in some cases, we'll just, if that's the case, we'll just leave it as plus or minus root 15. And it doesn't really matter what's over here. I'm still trying to solve for x. So I need to take the requisite steps to solve for x. So I'm going to subtract 1, I'm going to divide by 6, and we're just going to have something on the right side of the equation of what would be left over. So minus 1, minus 1. It doesn't really matter where you put the minus 1, either in front of the root term or after the root term. Typically it's going to be put in front though, so minus 1 plus or minus root 15. And then we can divide by 6. Our answer doesn't look very nice, but that's because our answer isn't very nice. And it's okay to leave it like that. There's no simplifying to do from there. If we could simplify the root, we would. If we could reduce our fractions all over the place, we would. But in this case, there wasn't an option to do any of that. But all right, so there's the square root property. Check back in, and we'll do the second half of 9.1 with completing the square.